Okay, in this video we'll be talking about calculus, just some basic concepts of calculus, and we'll be starting with tangents and limits. Okay. Here are the specific goals for this video. I want you to be able to know how to find how steep a curve is at a certain point. So if I have a curve that looks like this, how do I know how steep it is at here, how steep it is here, how steep it is here, and so on, assuming that we're given this particular point. Okay. I want you to be able to understand what tangent lines are and how they are used in calculus. We're going to talk about limits, and we want to be able to find the limits of certain expressions. And then I want you to be able to find the gradients of these tangent lines by using limits. Okay, so we're going to be tying everything together at the end. So let's start with an introduction into what calculus is. What exactly is calculus? Well, calculus is really just a branch of math, and it connects. It's a very interesting branch of mathematics and has lots of applications. But basically, it connects functions, the equation of a function, with the gradient of the tangent at any point on the graph. So if I have some function like this, okay, let's say this was f of x. What calculus will do is it's where we're studying this curve. We study a curve and we start using tangents with this curve. Okay, and we'll talk about what the tangent will do for that. Okay, basically these are what tangents would look like. Okay, but we'll go into this in more detail. The two major branches are differential calculus and integral calculus. We'll be starting with this part today. Okay, differential calculus. So let's start. Basically, our goal, I mentioned it before, is our goal is going to be to find out how steep a curve is at a particular point. Okay, so how steep is the curve right here? How steep is it right here? Okay, it looks pretty steep. If I were to draw a line, okay, that looks pretty steep, right? Right here, it doesn't look that steep right there because there's a maximum point here. Okay, so we're going to be investigating how basically how steep this curve is. Okay, as I go left to right, how steep the curve is at different points on a function. Okay, and we're going to do that by using slopes or gradients of tangent lines. So these numbers, okay, we know how to find the slope of a line, right? Y equals mx plus b. Okay, well this is going to be the slope, right? That's our gradient. Okay, and what that will tell me is it will give me a number. This m, the slope, is a number that will measure how steep the curve is. Okay, basically the bigger the slope, we know that the steeper my curve will be. This is if I have large slopes. If I have a zero slope, you know that a line will look like this. And if I have a negative slope, you know that it looks like this. So we can use these slope numbers, okay, to describe what's happening on this curve. Okay, so we've pretty much talked about this already, but what is a tangent? A tangent basically is a line, a straight line that touches any curve at one point. Okay, so this would be a tangent on a circle. This would be a tangent on a parabola. If it touches any 2 points, okay, that is not a tangent. That is a secant. Okay, that is a secant line. So the tangent will always touch only at one point. Now, actually, sorry, let me back up. It doesn't necessarily touch just at one point, but at the point of interest, it only touches once. Okay. All right. So how do we find tangents to lines? How do we find? Sorry, that should be how do we find tangents to curves? Okay. So again, if I have this curve, how do I find the tangent at this point? Okay, right at that point, how do I find the tangent there? Okay, there's a couple ways we can do it, 3 ways actually. We can estimate by using graphs. So if I were to draw this to scale, I could, okay, if I went back here to this slide here, okay, if I went back to this slide, I could just estimate by using, you know, if I said I want to find the value of the slope of the tangent line at this point, I could, you know, just try to draw it, eyeball it as best as I could. Okay, but that's not very accurate, right? It's crude. Okay, so how do we find, what's another way we could find the tangent at a curve? I could use quadratic theory, and this is a method that's talked about in 25A. You can look at that. We won't be going into this because I don't think it's particularly useful um, for what we'll be doing. Okay, this only is limited to certain functions, quadratic theory. But we want to use a broader method that will work with all functions. Okay, so this will not work. Um, this we will not be using, I should say. So what method will we use? We'll use a method called limits. Okay, and this is a type of math. This is a new math concept that we'll be talking about, and limits will help us find these tangent lines at certain points on the graph. Again, why are we finding the tangents? Because we want to describe how steep the curve is at a point. Okay, if I want to find out how steep this is, I take the tangent and I measure the tangent slope there. Okay? Alright, so what is a limit? Let's start by defining what a limit actually is. If f of x can be made as close as we like to some real number a, okay, by making x sufficiently close to but not equal to a, alright, then we say that f of x has a limit of a, right? So this is, we have a big A and a little a here, has a limit of big A as x approaches little a, and so we write the limit as x approaches a certain number of an expression f of x is big A. Okay, that just sounds like a bunch of mathematical jargon. Okay, it doesn't make a whole lot of sense. So let's explain that, what that means. What that's saying is, okay, what is a limit? Well, a limit looks like this. Okay, I have a limit as x approaches some number. Okay, let's use, in this example, let's use an example of 3. If I say, what is the limit as x approaches 3 of some function x squared? Okay, now let's talk about what this means. This is saying on the curve x squared, okay, so this is my curve x squared, this is a parabola, what is happening to the y value as the x value is really close to 3? Okay, so if you look carefully here at this picture, we have 2 red arrows, and they're getting closer to the value. I'm moving my x value closer to the number 3. Okay, so as I move my x number closer to 3, okay, what is happening to my y value is what really what it's saying. Okay, so let's see. As x gets closer to a, little a, okay, let's say this was a, okay, x equals a. As x gets closer to a, the limit, oops, okay, the limit, sorry, I'm running into some technical difficulty here. The limit, okay, as x gets closer to a, f of x, okay, gets closer to some y value, okay? I'm running into some real serious problems here, okay? Gets closer to a y value, okay? And that y value is called the limit, okay? So this y value here, in this case, is 9. It's getting closer and closer to 9. Okay? So the limit as x approaches 3 of x squared is actually 9 in this case. Okay? Um, okay? As x approaches 3 from the left and as x approaches from the right, okay, as x gets closer to 3, what's happening to the y value on the curve? It's getting closer and closer to the value of 9. So that's really what the limit is. This is the limit. 9 is the limit. This number is the limit of this expression x squared as x approaches 3. Okay, let's look at this example here. Okay, let me erase this. Okay, even if there's no value of f, in this case, okay, in this case, f of x is the same as the limit. Okay, in this case, f of 3 turned out to be 9, and the limit as x approaches 3 of x squared was also 9. Okay, so in this case, it turns out that the y value is the same as the limit. Okay, but this is not always the case. These two numbers can be different. Okay, these two numbers can be different, and that's why this limit concept is kind of confusing to people, is because the limit is what happens to the y value as it gets closer to some x value. Okay, to this 3, as it gets closer to 3, what y value is being approached, and it's only looking at what's happening as it approaches. Okay, as it gets really close to this point, what is happening, and it doesn't actually tell me what that point on the graph would be. Okay, and here's an example of this. If I take f of x equals x squared over x, and I were to graph this on my calculator, I would actually get this graph. Okay, it would be a straight line. Okay, but because the denominator has an x in it, okay, this, if I plugged in 0, if I wanted to find what this graph would look like at the point 0, it would be undefined, right? This would be 0. If I plugged in, if I plugged in 0 in for x, I would get 0 over 0. Okay, that would be, I would have an undefined point, and so this point actually doesn't exist on this function. Okay, but the limit of this graph, the limit of x as x approaches 0 here. Okay, I've changed the point that I'm interested in. Okay, this point is the point that I'm interested in. I've changed the point to x equals 0. Let's see what's happening right there. The limit as x approaches 0 of x squared over x is actually, just by looking at the graph, you can see that it looks like it's getting closer to 0. Okay, it's getting the y value. Remember, this is the y value. This y value approaches 0. Okay, but what happens if I put f of 0 in? Okay, if I put 0 in here, I get 0 over 0, and that's not possible. It's undefined. Okay, so you can see here that this limit is different from the actual value, the actual y value. Okay, so that's just an important concept to realize. The limit is the value that the y values approach. Okay, but it's not necessarily going to be the same as the actual y value that is on the curve. Okay. All right. So we've looked at these two examples. How do we actually find limits? Okay, and this is where we start. I'm going to teach you the process of finding limits. Okay. To find limits, we do the following. We substitute the value of x, whatever x value that we're approaching, into the expression. Okay, so let's look at this first example. All right. It says find the limit as x approaches 2, and this is how we read it. What's the limit as x approaches 2 of x cubed minus 1. Okay, so this would be my curve. This would actually be my curve. And I need to find what is the y value going to be, what's it going to approach as I move closer to 2 from the left and from the right. Okay, but I don't want to be graphing this every time, right? Because it gets kind of tedious, and maybe I don't have my calculator. So what we do is we substitute the value of x into the expression. Okay, oftentimes if I can substitute x in, if I can substitute 2 in and I get a real number out, then that is the limit. Okay, so I plug in 2. If I put 2 into the x values here, okay, this would be the same as 2 cubed minus 1. What's 2 cubed minus 1? Well, that would be 8 minus 1, so that would be 7. Okay, so x cubed minus 1 approaches 7 as x approaches 2. So the limit of x cubed minus 1 is 7. Okay, so notice here the way that I did it was a little bit faster than this. Okay, because we substitute the value of x. We substitute this number and we put it into here and then we solve it. Okay, so that's how we find limits. Now, there are going to be cases where this method doesn't work. If I try to substitute, I'll end up with something like this, right? If I were to just directly substitute into here, I'd get 0 over 0, and that would not work. Okay, so this method of direct substitution only works if the point and the y value, the limit and the y value are the same. Basically, if the denominator does not lead to, does not become 0. Okay, so let's look at an example where it does become 0. Okay, so if I were to try this substitution method first, okay, I would plug in 0 in here, and I would get 0 squared minus 0 over 0. But that's 0 over 0, right? So that's undefined. That's not going to help me. Okay, so we can't use this method of just putting in substituting this number in here to find the limit. All right. So what we have to do now is we can actually try to eliminate this guy. Let's try to get rid of this bottom factor. And the way we do that is we factor the top and we cancel out the denominator. So if I factor out an x, I have a common factor of x. If I factor out the x's here, what I'll get is x times x minus 1 all over x. And then the x's cancel. So now I have this expression, and now I can substitute. Because now it looks something like this, where I can substitute and I get a real number. Okay, so if I put 0 into here, I would get 0 minus 1, which would be negative 1. And that's this answer here, isn't it? Okay.